Okay, so a set of data that is normally distributed has a systematic bell shape when graphed as a frequency polygon. General measurements of living things such as mass, height, and lifespan have this type of distribution. The properties of normal distribution are as follows. The mean, median, and mode are all close to equal and fall at the vertical line of symmetry. So the bell curve, like I mentioned yesterday, is perfectly symmetrical. Half of the information or half of the data will be below the midline and half will be above the midline. That midline is also called the line of symmetry because it divides it into two equal parts. Okay? The amounts of data within 1, 2, or 3 standard deviations of the mean are as shown in the graph. So that tells you that when we do the graph again, my average, mean, median, mode will all be right along this symmetry line. But what it says is that within 3 standard deviations of the mean, above and below, you will have, I know those looks like 6s, but it's all I got. So between there and there, you're going to have 97.5% of your data will fall between this guy and this guy right here. Okay? Now, closest to the average, you have 34% of your data. All right? So within 1 standard deviation above and below of your average, 68% of all your data is going to fall in that area right there. So if you took 100 scores on a test, you averaged them, threw them on this bell curve, you'd find that 68 of the scores would be right in that area right there between 1 standard deviation above and below. So let's say that the test average was 70%. And the standard deviation was 4%. That means then that 68 of the students, 68% of the students would have scored between 66% and 74% on your test. Okay? That's how this works. All right, so now knowing that then, how many students actually scored above 66%? How many students scored above 66%?
31%.
So I'm asking you how many scored from here that way?
44%.
How much?
44.
44%? Where'd you come up with that number?
You're out of 100%, so you couldn't ask me more than 66.
No. You're using the wrong percentage. Okay? And that's the hard part about this. I'm saying that the average test score was 66%. So I want to find out how many kids scored higher than that. That's what this tells me. All right? How many scored from here out? How many score greater than the average? 50. 50% of all the scores will be greater than your average, right? That's what makes it the average. So then, how many would score 1 standard deviation below and above that point? What is it, Casey?
84%.
84%. 34 here and 50 over here. So that means that 84 of all the 100 students would have scored better than 66% on that test. How many students scored less than 66% on that test? 16. That's from here up this way. Only 16%. Okay? The whole graph is 100%. The whole chart is 100%. 50% are on this side, 50% are on that side. So when you break it down into your percentages, that just tells you how many people scored there. Not what their score was on the test. That's down here. This just tells me how many people out of 100 or out of 1,000 scored that greater or that smaller. Okay, and that's what the bell curve does. Let's look at an example here. Okay. It says, the ages of the grandparents of Elaine's classmates were collected. Does the data approximate a normal curve? Sketch a graph to help you. Okay, so they broke this chart down I'm just gonna follow through the workbook, because realistically, you should be doing this on a calculator. But we don't have enough graphing calculators to do it. So you would have to use that chart that we did the last 2 days in order, bless you, in order to solve it, okay? So, looking at it, in step 1, they checked the fit with a normal curve. So they calculated the average, which was 72.1 years. The standard deviation is 7.4 years. Okay, so let's take a look at this. Let's change this chart. So I'm just going to erase all the information here so that it's not so cluttered. Okay, so this is minus 1 standard deviation right here, minus 2 right here, and minus 3 right here. This is plus 1, plus 2, and plus 3. So they follow that chart at the top of the page, on page 122. The percentages are all broken down on that chart. I'm not going to write them into clutter, but you understand what I'm saying. They're all a part of that. Okay, so what was the average age of the kids' grandparents? What was the mean?
72.1.
So 72.1 was the mean average. Okay? What was the standard deviation?
7.4.
7.4. So that means that this is 7.4 greater than that. So that's 79.5. Right? And then this 7.4 greater than this. And then 7.4 greater than that. What was that?
94.3.
94.3. Thanks. Okay, 7.4 less than this. Alright. Now 7.4 less than that.
57.3.
Okay, and less than that.
Sorry, 49.9.
Thanks. Thanks, Marshall. Okay, so now, if I'm looking at my chart, how many of the kids' grandparents, what percentage of the kids' grandparents were older than 64.7?
84%.
84%. Right? 34 here, and then 50 over there. Okay? So, looking at these percentages now. This one here is 13.5. This one is 13.5 here. Okay? So what percent scored of the grandparents, the kids' grandparents? All right? How many of them were less than 57.3 years old?
.35%.
So this is 2.35 right here, right? If you look close enough, that's actually 0.15 here. So what does that make?
2.5.
2.5. So if the number of kids that had grandparents younger than 57.3, only 2.5% on that chart, or 2.5 of those kids on that chart, their grandparents were less than that age. Okay? What age range did the kids' grandparents, were they between 64.7 and 86.9? Well, minus 1 to plus 2, what percentage is that?
81.5.
81.5?
Yeah.
34, 34, and 13.5. So that's your percentage. Okay? So this is what we call a normal distribution curve. Some will call it a bell curve. So the first thing you need to do is you find out this average first. Then you plot in your standard deviation values, and then you just use the chart to answer the questions. Okay?
Can you do a problem that for the standard deviation to go over again?
Do the standard
Yeah,
deviation?
find it.
Okay, so that's that chart that we did the other day, right? Okay, so let's look at the already created chart on page 123, the start of it. So now we got the midpoint and the frequency, right? So what do we do with the midpoint and the frequency? Well, we multiply those together. Okay? So find your chart information from the other day. Find your chart information from the other day. So when I do f of x, what am I taking? I'm taking the frequency times the midpoint. Agreed? All right, get your calculators up. So I have this one is, the first one is 57.5. Now I have 62.5 times 4. Sorry?
250.
250. Perfect. Thanks. 67.5 times 5.
337.5.
72.5 times 12. 77.5 times 4.
310.
82.5 times 4.
330.
87.5
92.5.
and 92.5. Okay. So now that I had f times x, what's the next step according to your graph, your chart?
Square
I don't think so.
Add them all together.
Okay, so I add them together to find what?
Your sum.
My total, right? I need to find my total.
Uh, 31,202.5.
Okay? And then I divide it by the total number in the class, and that should give me the average.
That's big. I missed the addition of 1,005. Not big, no.
Oh, good job, Marshall.
I got 2,035.
Yeah,
that's what I got.
2,355. You missed
2,355.
300.
Right on the nose?
Yeah.
Okay? So now we're going to take that number and divide it by the total number in the class, which was how many? 32?
Yeah.
And that should give you my average.
72.9689.
969.
Oh, okay.
969?
If you round, that's 969.
Okay, so 97. We'll just put it as that for now. All right? Okay, so that's my average. So we'll actually, let's just make it easier on ourselves. Let's put it to 73, okay? So now what do? I take my midpoint and I subtract my average, correct?
Yeah.
Yeah.
Midpoint subtract my average. So the first midpoint is?
57.5.
So 57.5 subtract 73. What do I get?
Negative 15.5.
Good. Okay, 62.5 subtract 73.
Negative 10.5.
67.5?
Negative 5.5.
72.5.
-0.5.
77.5.
4.5.
9.5?
Yeah.
And then
14.5.
14.5 and
19.5.
19.5. Okay. So now what do I do with this column here?
Square.
Square them. That's right. So square, 15.5 squared is? Sorry?
240.25.
10.5 squared?
110.25.
5.5 squared?
30.25.
0.5 squared?
125.
4.5 squared?
20.25.
9.5 squared?
90.25.
14.5 squared? 5
2.5?
2.5.
Thanks. And then 19.5 squared?
380.25.
380? Good. Now, we need the sum of them.
$1,082.
Sorry?
1,082.
1,082.
And 82.
Decimals? Okay, so I have 1,082. Now I have to divide that number by 32 and take the square root.
$5.81.
What'd you get?
5.80.
Okay. Well, we're off on theirs.
Because we rounded it.
Possibly.
But they usually round it, don't they?
Yeah, it's, oh, this. Yeah, they would have used 72.1, right? So that would have been a big difference. That's 0.9 off on all of these calculations. So it would have made a big enough difference. Okay? So this is what we have. So this is that chart we did the other day. So if you don't have that chart down on your cheat sheet, you need to have it down. Because you're going to need it. Fair enough?
Are we gonna need that chart that we just did with like the 68% of 34?
Are you going to need that bell curve?
Yeah.
No, I think I'd give it to you. Because it's, yeah, I don't think I.
Yeah.
You'll have it one way or the other. Either you'll have to put it on yourself, but I'll know before the test.
And then that's.
I'll look at the test.
Is what, from your average on your bill, because that's what it goes up by and down. Like, you take your average and you add your standard deviation.
Yes.
Okay.
Okay, this is a good question. I take my average, and then I use the standard deviation to add to it to get to the next ones. And I subtract to it to get to the next ones on my bell curve. Okay? So that's a very legit question. Unlike every other question here.
Thanks.
Okay, are there any other questions from yesterday?